All right, I'm back. I'm still, it turns out, on page 241. We're gonna like read through this, generalize it, and then kind of like move on to more calculator stuff. So the first thing that I notice is that there's like a typo in the notes that has survived for like a decade, and I don't recall anyone ever mentioning this to me. So approximate volume from rotating f of x from delta x to x equals b? No, no, no. From x equals a. How did this, how? How has it survived this long? So this should say from x equals a to x equals b about the x-axis. So if we're going to approximate that volume, the volume is approximately the sum from I equals 1. So this is like the first cylinder to n, the last cylinder. So if you're going to do 52 cylinders, n is going to be 52. Pi, this, not the squared part, just that. This is the radius. And then this is the height. So I can't believe that typo has made it. I might go in and change that as soon as I'm done with this video. I also might not, and knowing me, I won't, but like, who knows? I might. So it's pi, the radius squared, times the height. Just remember that, pi r squared h, and then like start really thinking about what's happening. How are we slicing up the x-axis? Where are our evaluation points coming from? So this, delta x, is our height. And it's just that you have to make an even number of intervals, right? You need each of them to be the same width. So if you're starting at A, ending at B, and you're cutting it into equal parts, it's always going to be B minus A, the distance between them, divided by N. That's going to be the height of each of your cylinders. X sub I is called an evaluation. Man, you start writing in red and you just go with it. These are evaluation points. And it's always where you're starting plus I, the number of the cylinder that you're in, times delta x. So if you want to be in the fifth cylinder, you're going to start at A and add delta x 5 times. That gives you the right endpoint of that cylinder. That's the right endpoint. You plug it into the function. You go up. That's the radius. You rotate it. It's all related. Think about it as much as you can. Try to draw some. It all comes down to rotating a rectangle. Like when you rotate a rectangle, you definitely get a cylinder, and that's kind of where it comes from. So this is more just in words. So it's pi, the radius squared, times the height. I don't know why I put the height before the radius squared. That looks really weird to me right now, but what are you going to do? Just from using summations, you should remember this, hopefully. I in that summation is not the complex I. It's just I. It's just a counter. Sometimes you use J. Sometimes you use K. On the college AP exam, they use K frequently now. I don't know when they made that switch. It's really hard for me. I don't know if I'll ever make that switch. But I, that little thing that you're counting by is called the index, and it just represents a counter. So it's always going to count by ones. You start counting at 1, and you just go up until you hit that top number. And in our case, it represents the cylinder you are currently finding the volume of. So you could find, if you had 100 cylinders that you were using, you could actually find the volume of the 75th cylinder by just letting I equal 75 in all of our formulas up here, which really just means an x sub I. And then you sub it in, and don't do the summation. It'll just give you the volume of the 73rd, or whatever number I chose, cylinder. So it's really interesting. I really enjoy working with these. So you should try to think about it. Think about as much as you can. What we want to do now is we want to create and store a volume function on RTI Inspire CAS. And we want it to be a function of n. So n is the number of cylinders. And we're still doing the same problem. We're going from 0 to 4 of x squared, going around. We know that it gives us kind of a horn shape, or like a thumbtack, kind of like a push pin type of thing. So what I'm going to do, switch over here and share the calculator. I think I'm going to start a new document. And how can I do this? So I'm going to say v of n, and then colon equals, so control in the templates, the sum, so I'm going to hit the templates button and choose the summation symbol, from I equals 1 to n of pi, never forget the pi, the radius. So right now I know that something bad is going to happen because I never defined the function. That's a really common mistake on the calculator, and I just made it, so you're welcome. It's going to be, the radius is the function evaluated at the evaluation point. So it's the function at the evaluation point. The evaluation point is where you're starting, so 0 plus I times delta x. So delta x is where you stop minus where you start, so the total distance along the x-axis, which in this case will be 4 minus 0, divided by however many cylinders you're going to make. So in this case, the number of cylinders you make is n. Over n, you have to square your radius, so it's pi, the radius squared, and then times the height, but the height is just delta x again. And this is it. This is a very powerful formula. So I'm going to hit enter. So let's see. We've already done a couple of these. So if I do v of 2, I should get whatever I got. I think it was 544 pi. And I get this. Why am I not getting that? The thing I previously mentioned. I never defined f of x. So f of x for this particular problem is x squared. So like, check out what it did though. It's pretty instructive. It did, I don't know what it did. Is it instructive? Sure it is. This is delta x is 2 pi. So this is the height right here. This is pi. And then it tried to do f of 4 and square it. So f of 4 is the radius, square the radius. Here it did 2, which is delta x. That's the height. Pi is pi. F of 2 is where you find the first radius. That is the first radius, right? Because you start at 0. You have delta x is 2. So now you're at 2. Plug it in. That's f of 2. Square it. And you got your circle, your cylinder. So it made sense, but not what I was looking for. This is what I was looking for. Then if I do v of 4, I get 354 pi. This is pretty good. So now what I'm going to do, I'm asked on the notes, so I'm going to like find these so that I can use them. I'm asked to find a bunch of them. So v of 10, I'm going to use decimals because it's just a little bit easier. It says to 3 decimal places, so that's annoying. Oh, okay, that is to 3 decimals. That is to 3 decimals. 25, v of 50, v of 1000. So notice they're getting smaller every time, which makes sense because we're always overestimating. So like go back a page or two and look at the picture. All of our rectangles that become our cylinders are overestimating the region. So it makes sense that as we make more, we'll be less wrong, so the number will get smaller. And then v of 5000. Usually when you use 5000, you're like very close to the like final accurate thing. I hate the way these keep coming up as I think I call that cascading rounding. Let me do that one more time. Hate it. So like you got to round to 3 decimal places, right? That's like to get ready for AP calculus. So 643, fine. 0.7199. Ugh. So to round to 3 decimal places, because it's 9, you go up. So then this becomes 10, which goes up. And it's like dominoes, just knocking your decimals out. And it's terrible. And it's unnerving when you want 3 decimals and you only get 2. And you're like, wait a second. Okay, so I'm going to go back to the notes and fill in some things in that chart. And then I'm going to come back to the calculator and do one more thing. And then maybe I will call it a video for this. So back to the notes. Call it a video. It's like calling it a day. All right, so let's see if we can fill some of this in. We can fill in a lot by hand. And then I need to take a look at the calculator again to get the other values. So delta x is going to be b minus a. Let me get, I'm just going to use black here. So it's b is 4 and a is 0. So this will be 4 over 10. And we could just do all these. 4 over 25, 4 over 50, 4 over 1000. So it's always the distance along the x-axis, which is why the numerator is always 4 for this particular problem. Oh, 5,000. That's it. You try to talk and explain at the same time. Talk and think at the same. You have to talk to explain. Okay, and then x sub I is also very, very similar, right? They're all going to be where you start, which is 0, plus I times delta x, so 4 times I. Ugh, what I is that? I. And then it's going to be 0 plus 4 over 25i, 0 plus 4 over 50i. If this is making sense to you, that's amazing, because, not because I'm doing a terrible job. I hope that's not the case. It's amazing because this idea is bigger than you know. This is going to come up a lot. Slicing things up and then adding up what you get. It's all over the place. You're going to be doing it a whole lot. So now I got to put in these 3 decimal approximations. This looks weird to me. So I'm going to say this is 814, because right now on my computer screen, I can see my calculator, but I'm pretty sure you are seeing what I'm writing. I hope. Either way, I'll be back to do it, or at least read it, or make sure. I don't know. Maybe I won't even do that. I don't know. Crisis of confidence. There we go. 645.008. Spend a lot of time looking down in these videos. Woo, where are we going? And then 643.720. Okay. So the difference when we did, let me go back to the calculator. The difference between using 1,000 cylinders and 5,000 cylinders was less than 2. So we're getting pretty close. So now the question is, what would happen if we use an infinite number? Can we use an infinite number? Well, it turns out that the calculator can use an infinite number. So let's actually do that. So what I'm going to do is I'm going to press the templates button. And if you've never done it, it's in the last row. Just find it, because it's probably different on your calculator, like CX1, CX2. I don't know why they had to change that, but not all the templates are in the same like row and column anymore. But anyway, we want this one, the limit one. So I want the thing that's going to change is n, so I want the limit as n, and then the thing it's going to go toward is infinity. So I'm going to put infinity, and then the function is named v, and it's a function of n. So I'm going to press enter and see what I get. Whoa, I get 1024 pi divided by 5. Let's see what that is as a decimal. 643.398. Check that out. The difference between doing 5,000 cylinders and an infinite number of cylinders is like basically 0.33. Like, is it even worth it? I mean, it's worth it because we could find the exact value potentially somehow. But in actuality, we need to know a lot more to be able to do that, but the calculator can knock it out right now. So 5,000 cylinders was plenty to get very accurate. An infinite number, if you know what you're doing, can give you exactly 1024 pi over 5. And that's pretty amazing. So what I'm going to do is I'm going to stop the video here, come back and do just more stuff in more videos. So I hope you are finding these helpful.